Have you ever wondered how integrated circuits work in your electronic devices? Well, let's dive right into the fascinating world of these tiny marvels that are the heartbeat of our digital age. Integrated circuits, fondly known as ICs, are compact arrangements of tiny electronic components like transistors, resistors, and diodes. They are ingeniously designed onto a small chip of semiconductor material, typically silicon. Imagine a bustling city condensed into a tiny speck. That's essentially what an IC is. These microcities of electronics are everywhere around us, in our phones, computers, televisions, cars, even our kitchen appliances. And just like cities have different districts for different purposes, ICs come in different types too. We have digital circuits, the brains behind computers and smartphones, and analog circuits, which are the heroes of our radios and televisions. In essence, integrated circuits are the unsung heroes of our modern digital civilization. Now that we know what integrated circuits are, how do they actually work? Integrated circuits, also known as microchips, are like mini cities of electronic components. These tiny powerhouses are the lifeblood of all modern electronic devices, from your smartphone to your car's navigation system. But what actually happens inside these intricate labyrinths of silicon and metal? Let's take a closer look. The main components of integrated circuits are transistors, resistors, and capacitors. And like a well-oiled machine, each part has a specific role to play. Transistors, the superheroes of the integrated circuit world, act like switches. They control the flow of electricity, turning it on or off. Imagine them as the traffic lights of our mini electronic city, directing the flow of electrical traffic. Next up, we have resistors. These components control the amount of electricity that flows through the circuit. Think of them as speed bumps, slowing down the electrical current to prevent any potential damage to the circuit. Lastly, we have capacitors. These are the energy storage units of the circuit. They store electrical charge and release it when required. Picture them as water towers, holding onto electricity until it's needed elsewhere in the circuit. These components, working together in perfect harmony, process electrical signals. The transistors switch the current on and off, creating a series of electrical pulses or bits. The resistors control the speed and intensity of these pulses, while the capacitors store and release energy as needed. This dance of electrical signals is what allows integrated circuits to perform complex tasks. Whether it's processing a Google search, playing your favorite song, or even launching a rocket into space, it all comes down to the intricate choreography happening inside these tiny microchips. But these components don't just magically appear on the silicon. There's a complex manufacturing process behind every integrated circuit, involving state-of-the-art machinery and cutting-edge technology. Now that we understand the inner workings of integrated circuits, let's delve into how these marvels are made. Creating an integrated circuit is a complex process that involves precision and a lot of technology. Let's delve into it. The journey begins with a slice of silicon, the bedrock of any integrated circuit. This silicon wafer is then coated with a light-sensitive material known as photoresist. Next, the magic of photolithography comes into play. A mask, which is a blueprint of the circuit, is prepared and illuminated with ultraviolet light. This light then transfers the circuit pattern onto the photoresist-coated silicon wafer. But we're not done yet. The next step is etching. This is where unwanted silicon is removed, leaving behind only the desired circuit pattern. Acid is commonly used for this purpose, eating away the exposed areas of the silicon wafer, and voila! What remains is a meticulously crafted, integrated circuit, ready to take its place in the heart of your favorite electronic devices. So, from design to fabrication, integrated circuits undergo a fascinating process. Incredible, isn't it? The tiny integrated circuits play a massive role in operating our electronic devices. We've journeyed through the fascinating world of these micro marvels, understanding their essence, their function, and their creation. We've discovered that integrated circuits, often no larger than a thumbnail, are the lifeblood of our gadgets. These miniaturized electronic circuits, composed of various components such as transistors, resistors, and capacitors, perform tasks ranging from simple amplification to complex data processing. They are the silent heroes that make our modern world tick. And let's not forget the intricate process of manufacturing these circuits. a dance of precision and technology that brings them into being, ready for their crucial role in our devices. Remember to hit the like button if you found this video informative and subscribe for more content like this. Thanks for watching and stay curious.